And welcome back to our lesson 5.5, Graphs of Relations and Functions. We want to take a little closer look at this idea of domain and range. We introduced it last class, but now we want to really get to know it much better. So again, a quick reminder that the domain is what we call my independent variable. The information is found on the x-axis. The range is my dependent variable. And of course that information is found on the y-axis. And a function is just simply when one or each value of the x is associated with exactly one value of the y. These three ideas were from our last lesson, just giving us a basis for today. So we want to look at another way we can see if we have a function. And it's another way to look at this idea of one value of x with one value of y. It's called the vertical line test. So if you perform a vertical line test and it passes, you will have a function. If it fails, then you don't. For the vertical line test, we need a graph. And we're going to take the function if no 2 points on the graph lie in the same vertical line. So we're going to look at our graph, take a vertical line, so we could use our ruler, whatever we want, and if no 2 points fall on that same vertical line, you've got a function. So let's look at what this means for us. Two graphs here, number 1, number 2. The first thing I'm going to do is I'm going to get my ruler. So for here, I'm just going to grab a straight line. And of course, move it around, get it nice and straight. Looks good there. And I'm going to darken it up. So what I want to do is I want to take this line and I'm going to move it across my graph. And I'm just simply going to start on the left, start on the right, and move it across. I got a point, only one on that line. I got a point, only one, only one, only one, only one. So this first one here looks like I've got a function. I can't find any points on my graph where 2 dots hit my vertical line. So this is a function. Let's take a look at my second one. Grab my line again. And I'll start on the left, just the way I like doing it, and I come along, come along, come along. Uh-oh, I've got 2 points right here. So right away I know this is not a function. Keep going, 2 points right here, another one. Well, that one's good. 2 points again, and that one's good. So here, here, and here, I've got 2 points hitting my vertical line. Therefore, I do not have a function. Not a function. So example 1, not a function. Example 2 was a function. So another way we can test for is vertical line test. Okay, let's flip the page here. So on a graph, the domain or range is restricted to a set of discrete values if the points of the graph are not connected. So what does that mean? Well, let's start with discrete values. Discrete values means actual whole numbers. So when we have points on a graph like we do here, our domain and range will actually be specific numbers. So let's take a look at this. Start with my domain. Now my domain are all the points on my x-axis. So where do these points fall on just the x-axis? I'm going to open up a set of brackets, and usually I start working with my smallest number, my negatives first. And I've got points falling at -2. I've got points falling at 0 on the x-axis. I've got a point falling at 1 and at 3. So my domain for this graph is -2, 0, 1, and 3. Those are the values of on the x-axis where I'll find my points. I'll find 2 of them here. I'll find 1 at 0, 1 at 3, and 1 at 1. Let's take a look at my range. And again, we've got points, we've got discrete values. So my range is where these points cross my y-axis. And again, I'm going to start at the bottom. The point crosses my y-axis at -3. Crosses my y-axis at 1. At 3, and at 4. So the range of values is -3, 1, 3, and 4. So I have a specific domain and a specific range. Just curious, is this a function? Well, I can pull up my ruler and do the vertical line test again, or I can come and take a look, and I will take my ruler out, so I will insert my ruler. My ruler is just a straight line. There we go. I'm going to grab it and come across. Oh, I've got 2 points right there. 1, 1, 1. So I do not have a function. So this is not a function. So when I've got specific points on my graph, my domain and my range are pretty simple. Just find where the points meet the x and the y-axis. But now what happens when I don't have points, when I've got actual lines, connected lines? So on a graph, the domain and range is a non-restricted set of non-discrete values if the points on the graph are connected. So non-discrete means I'm not going to have specific numbers. So in this case, I've got to use inequalities. So think back to grade 9, what's an inequality? Well, inequality is stuff like this. X is greater than 2. Y is less than or equal to -3. So in inequality, we've got our greater than, our less than, our equal to signs. This will allow us to do the domain and range for lines. So let's take a look at our first example on the left. We've got a curved graph, and these arrows indicate that this line would continue on forever and ever. Never ever stops. So what is my domain? And again, the domain is the x values. So this goes on forever and ever and ever, meaning that there will never ever be a time where an x value is not on that line. If I take the x of 1, it would join right there. X of -1, join right there. An x of 0.5, right there. X of 1 or 2.5. Now 2.5 is a little more difficult because it would join up right here. But you got to realize this line continues on forever and ever and ever and ever, ever. Never ever stops. So there will always be an x value, both negative and positive, that could cross this line. So in this case, we say that my domain is all reals. All the real numbers. So any number that I can think of, positive or negative, will cross this particular line. But now let's look at my range. My range is the y's. So you can see on my graph that my line is everything that is positive for the y's, all positive y's. There's absolutely nothing here that is negative. So in this case, I've got to say that my y any y value to fall in this graph would have to be greater than 0. If I get a y of 3, well, that's right there. It'll cross there. A y of 1.5, cross right there. But a y of -2, which is down here, never ever ever touches my graph. So y is greater than 0. But I have to do one more thing. I've got to actually look at the point 0. Can 0 fall on my graph? Well, yes, it can. So y doesn't have to be greater than 0. It has to be greater or equal to 0. So I put a little line underneath here. So my range is now y is greater or equal to 0. It means it could be 0, 1, 2, 0.5, anything on the positive side, which is exactly what my graph shows. Anything on the negative side does not match my graph. Okay, let's take a look at graph number 2. Start with my domain. So domain is where this line passes the x-axis. X-axis runs across. So clearly you can see that anything below -5 is not going to be on my graph. Anything above 4 is not going to be on my graph. So because we don't have arrows on my line, I can't say this goes on forever. If I don't have arrows, I'm going to have a small value and a large value. So I start by writing out the x, because it's still my domain. And then I ask myself, what is the smallest value for x? And it goes down to -5. All the way to -5 here. So now, can x be larger or smaller than -5? And the answer is it's got to be larger. So x has to be larger. The big part has to be towards the x. Now, can it be equal to -5? Well, on a graph, if we have a large circle here, this indicates that it goes all the way up to -5. -4.999999999, keep going forever, but it will never actually get to -5. So if it can't be -5, it must be just a little bit greater. So I do not put the sign here. It's just -5, x is greater than -5. And now let's look at my large end. Now it looks like it goes to 4. So x has to be smaller than 4. But could it be 4? Well, this little dot at the end here, it's filled in. So if it's filled in, yes, it could be 4, so I got to put my equal sign as well. So my domain, x has to be greater than -5, but it has to be smaller or equal to -4. Now let's look at my range. So again, my range is my y-axis. So again, we've got a line, so we have non-discrete points. So we start with a maximum and a minimum. I throw a y in the middle. What's the smallest y value that fits on my line? Go down to the bottom, and it looks like -2. So my y has to be greater than -2. Could it be equal to it? Well, again, no, because we've got this non-filled in circle at the end of my line. My maximum value looks like it crosses at 3. And it has to be smaller than 3. Could it be equal to 3? It's a solid dot, so yes, it could. So I put on my equal to sign as well. So my range, the y has to be greater than -2, but smaller or equal to +3. So when we have lines, our domain and range get a little more complicated, but if we know inequalities, we should have no problem. Okay, two more examples. One on the left. Let's start with the domain. Now again, domain is my x. I know I've got a line here, so I'm going to have inequalities. I throw an x in the middle. Now what is the smallest value my line crosses the x-axis? Right here. And that, of course, is 0. Can it be equal to 0? Well, yes, it can. We've got a filled in dot, so greater or equal to 0. What's my maximum? Maximum is 7. So it has to be less than 7. Can it be equal to 7? Well, you bet. So my domain here, my x has to be greater or equal to 0, smaller or equal to 7. And now my range. I like this example because it shows that the range, the maximum minimum for the range or the domain, does not have to be at the end of your line. In fact, my max and my min fall in the middle of my line. No big deal. You find the maximum wherever it is and the minimum wherever it is. So again, I've got a line, non-discrete values. I throw in my y. What's the smallest this goes down on the y-axis? Well, it looks like it goes right to there. So it is -2. So my y has to be greater than -2. Could it be equal to it? Well, when we don't have the ends, we have to say that this line does touch -2, so it can be greater. If it touches the line, throw on your equal sign. If it doesn't touch the line, then you wouldn't. On my maximum value for the y, looks like it crosses at 4, and it looks like it does touch 4. So I have to be smaller or equal to 4. So we read this as my range. Y must be greater or equal to -2, must be smaller or equal to +4. And finally, let's do example number 4. We've got my domain and the range. Of course, we're dealing with inequalities here, so I throw down my x for my domain. And where does it cross my x-axis? My smallest one appears to be at +2. So it has to be greater than +2. Can it be equal to it? You bet. So I throw my equal to sign. Maximum crosses at 8. Can it be equal to 8? You bet. We've got that colored in dot. So our x has to be greater or equal to 2, smaller or equal to 8. And now we've got my range, my y. Smallest value, well, we got a curved line here. So it looks like we've got -5 and greater than -5, but we could be equal to it. And at the top, looks like my highest is 9. And yes, it could be equal to 9. So I've got my range. My y has to be greater or equal than -5, smaller or equal to 9. Okay, if we are given a specific domain, we can use function notation or a graph to determine the corresponding range. And of course the opposite true as well. If I have the range, I can figure out the domain. So here's my function, and it's in function notation. F at x equals 2x plus 2. So we're going to determine the range when the domain is 8. So the domain is 3, sorry. So the domain is my x. My range is my y. In this case, the range is what we consider the f at x. So find the range f at 3, which equals 2 times 3 plus 2. Range is always by itself on the left. Domain is hidden in my equation. I'm changing my x's into 3's. So I have f at 3 equals 2 times 3 plus 2. 2 times 3 is 6, and 6 plus 2 is 8. So my range, when my domain is 3, is 8. This, of course, would be a discrete value. Now let's try going the opposite way. Determine the domain when the range is -1. So my range, of course, is the f at x. So it's -1 equals 2 times x plus 2. Now we have to think of a little bit of grade 9 math here. Isolating the x, we're going to get rid of this plus 2 by subtracting 2 to both sides. Plus 2 and minus 2 is 0, so that's going to give me 2x on my right-hand side. This is going to give me -3 on the left-hand side. I'm going to come and rewrite this up here so I have a little more room. Getting rid of the x, getting the x by itself, I have to get rid of the 2. It's being multiplied, so I'm going to divide each side. Multiplying, dividing by the same number to make it disappear. So I got my x to be equal to -3 over 2. So when my range is -1 for this function, my domain is -3 over 2. And you can choose any domain, any range, plug them into the formula, solve like we did, and you get your answer. Let's go to our textbook. Let's go to page 294. Let's do 2 of the A's, 6 of the B's, and 1 of the C's.